Welcome to Adeirsra's December webinar and our final webinar of 2025. It's hard to believe that 2025 is over already. Thank you for joining us today. In today's presentation, we will explore from the shop floor to the cloud, maximizing OEE everywhere. A look at how hybrid OEE strategies bring insights and efficiency to every level of our operations. Manufacturers today face mounting pressure to gain complete visibility into production performance, whether at the machine level, across an entire plant, or throughout multiple global plants. As OEE becomes increasingly vital for improving productivity, the industry is rapidly embracing a hybrid model that blends both on-premise and cloud-based solutions. My name is Marcia Gabois, and I have the privilege of serving as the general manager of Adeirsra. Over the years, I've had the opportunity to work across many areas of software industry, from artificial intelligence to industrial automation, and even led Indusoft through its acquisition by Inventus. Today, I'll be moderating our session and giving a brief presentation to set the stage. I'm excited to share how Adeirsra SmartView and InsightView come together to provide real-time accuracy of local monitoring with the stability, scalability, and intelligence of cloud analytics, creating a more resilient, efficient, and flexible foundation for today's manufacturing environment. I would like to introduce our presenter, Fabio Cavallo. Fabio is the VP of Engineering at Adeirsra and is responsible for Adeirsra SmartView, InsightView, and KnowledgeView. Fabio has over 21 plus years of software development experience with 15 plus years focused on HMI SCADA solutions. Fabio holds a bachelor's in computer science and is located in Brazil. I wanted to start with who we are. We are an industrial automation software company headquartered in Austin, Texas, with a global presence. Our mission is to empower manufacturers, machine builders, OEMs, and system integrators and distributors with next-generation tools that make it easier to build, deploy, and manage automation systems. At the heart of what we do are our three products: Adeirsra SmartView, an HMI SCADA package featuring a built-in AI system; InsightView, a cloud-based OEE solution with 6 major losses and advanced analytics; and KnowledgeView, a cloud-based predictive maintenance solution. Today, these solutions help our customers simplify development, reduce downtime, improve efficiency, and prepare for the future of digital transformation. Our products can be used independently or in conjunction with each other. Our products are designed to achieve unparalleled flexibility, intelligence, and operational excellence, paving the way for a connected, efficient, and sustainable future. In short, Adeirsra is about delivering smart, scalable, and data-driven solutions, backed by a global ecosystem of OEMs, machine builders, distributors, and system integrators. And it is your feedback and insights that allow us to continue to grow and evolve our product in the direction that is best for our customer base. Let's get into OEE. The demand for OEE software continues to surge, driven by smart manufacturing adoption, the need for real-time performance insights, and a push to reduce downtime and maximize asset utilization. North America continues to lead the market with 38% of global presence in 2024, fueled by a strong manufacturing base, rapid digital transformation, and the early adoption of IoT adoption. Asia Pacific, though, is the fastest growing region, propelled by a rapidly industrialization, government smart factory initiative, and increased lean manufacturing adoption. On-premise deployment still dominates with 56.3% market share, supported by data security requirements, customization needs, and strong operational efficiency. Future trends and also the need for legacy infrastructure that oftentimes requires an on-premise solution. Some of the key growth drivers include Industrial 4.0, IoT, and AI integration. powering the predictive maintenance, the real-time analytics that everybody wants to increase their productivity and efficiency. Future trends point to AI-driven predictive maintenance, digital twin integration, and continued expansion of scalable cloud-based OEE solution, along with incorporating hybrid. Opportunity remains strong across discrete manufacturing, process industry, and emerging smart factory initiative, where data-driven OEE insights enable continuous improvement. Most of you know this that are on the line. However, I just want to reiterate. Overall equipment efficiency, or OEE, is a universal benchmark for measuring manufacturing efficiency. Your OEE score acts as a real-time snapshot of operational health built on three key pillars, which is availability, performance, and quality. Each one highlights where losses occur and where to focus improvement effort. Availability drops whenever a machine stops unexpectedly, whether due to equipment failure, material shortage, or other unplanned downtime. Remember, planned downtime like breaks and lunches is excluded from OEE and instead belongs under OOE, overall operational effectiveness. Performance loss occurs when a machine runs slower than its ideal maximum speed. Quality loss occurs when units fail to meet required standards, resulting in scrap or rework. Any time one of these factors fall below 100, you are experiencing a measurable loss in time, unit, or ultimately dollars. By continuously monitoring and improving these three areas, you can unlock major gains across your entire production process. As many of you know, OEE was introduced in 1970 by Sashi Nakajima as part of the total productivity maintenance. He identified world-class benchmark as 90% availability, 95% performance, and 99% quality, which only results in an OEE of 85%. While these numbers are still widely referenced, real-world targets vary by industry, product mix, and operational strategy. When assessing your own OEE, it's important to account for the realities of your manufacturing environment. High mix, low volume operation will naturally differ from low mix, high volume manufacturer, and your KPIs should reflect those differences. On this side, we're just linking the 6 major losses to both operational performance measures and broader business objective. On the left are the performance measure operational team focus on everyday, reduce downtime, minimize rate losses, improve OEE, and increase asset utilization. On the right side, you see these operational gains translate into strategic business outcomes such as lower operating costs, higher plant reliability, better energy efficiency, improve labor efficiency. By targeting the 6 major losses, we strengthened our frontline KPIs and enterprise level values. Every improvement made on the shop floor directly supports long-term competitiveness. Focusing on the 6 major losses aligns operational excellence with strategic business success, driving short-term efficiency and long-term advantage. This slide just highlights the supporting diagnostic metrics that help us understand the fundamental drivers behind OEE. While the OEE scores give us a high-level view of operational performance, these underlying metrics tell us why availability, performance, quality are increasing or decreasing. OEE is influenced by the 6 major losses, and each loss category is paired with a specific diagnostic metric that quantify the true impact on productivity time. For availability loss, we look at unplanned stop, planned stop, metrics such as mean time between failure, mean time to repair, setup or changeover time reveals how stoppage, both expected and unexpected, reduce the time equipment is actually running. Performance loss is driven by small stops and slow cycles. Here, metrics is like this number of stoppage, average stoppage duration, and actual versus targeted flow rate allow us to measure how interruptions and reduce operation speed cut into performance. Quality losses come from production rejects and startup rejects. Diagnostic metrics such as reject rate helps quantify how defects lower the percentage of good units produced. Together, these support metrics connect the six major losses directly to the three pillars of OEE. They break down the gap between scheduled production time and fully productive time, giving teams a clear path to identify where losses occur and where improvement and efforts should be focused. OEE goes far beyond measuring individual machines. It provides a unified framework for comparing performances across lines, across plants, or even across global manufacturing networks, making it a powerful internal and industry-wide benchmark tool. But improving OEE requires more than watching KPIs. True improvement comes from identifying and eliminating the six major losses that impact availability, performance, and quality. Addressing these losses increase equipment effectiveness and delivers real business value. In today's competitive manufacturing landscape, every minute of uptime counts. Production lines must operate at peak performance to meet demand, protect margins, and justify capital investments. OEE remains the golden standard, but meaningful improvement requires proactive planning, skilled teams, and strong digital execution. Ultimately, the strength of OEE is its availability to connect shop floor performance to strategic outcome. When applied effectively, it becomes a catalyst for reducing waste, increasing throughput, improving competitiveness, and driving long-term operational excellence. Artificial intelligence, everyone hears the buzzword, everyone knows it refers to the technology that enables machines to perform tasks that normally require human intelligence. Within AI, machine learning allows systems to learn from data and past experience to improve performance over time. In industrial environments, AI is expected to do more than predict outcomes. It deepens process understanding, selects the right algorithm for each challenge, and delivers capability that our traditional methods can't match. This includes automatic quality prediction, full part traceability, process optimization, predictive maintenance, each of which directly influence productivity metrics like OEE and machine downtime. Here are just a few examples of how AI is transforming manufacturing operation, like faster setups. AI analyzes previous production runs to reduce setup and changeover time, shorter, more accurate setups, increase equipment availability, and improve OEE. Another one is reducing process deviation by predicting quality issues from real-time parameters and adjusting those parameters automatically. AI improves product quality and reduces scraps. Another major factor that would increase the OEE as well. Another one might be smarter maintenance, AI-driven predictive maintenance, which seems to be the big hot topic in industrial automation and AI. Identifies when equipment is likely to fail, allowing teams to plan repairs or order parts in advance. Once again, this reduces unplanned downtime and raises equipment availability. Together, these capabilities show how AI strengthens productivity and reduces scraps and improves OEE. So AI does have a role to play in the long term. So I know you didn't come here to hear my presentation, so let me turn it over to Fabio, who will be giving you the presentation on OEE, both on-premise and on the cloud. Let me introduce you to Fabio and stop sharing.
Thank you, Marcia. Let me start sharing my screen. Hello, everyone. Just a second. Okay, should be seeing my screen now. So I'll start the presentation with a sample that I developed, and I want you to understand what can be done not only in SmartView but also in SiteView, and how both data are connected, and how you can visualize and get insights from both solutions, okay, both products. And I'll start with the plant floor. So first we'll have the SCADA installed in the customer machine in the factory. And this is SmartView SCADA application will be collecting data storing data in the database, and it will do some calculations internally here as well, as I want to show that we can also calculate the OEE locally. And then we'll move to Insight View and understand how we can get the data that we just collected from the SCADA system and then apply all the analysis that Marcia mentioned. Okay. So starting on the plant floor, I will start with the application that I developed. And basically, this application contains 4 machines that I want to monitor. Okay, it could be different numbers of machines, but in this example, I have 4 machines in a line. Okay, so it's starting from the right side. As you can see, this machine here is a material preparation and feeding unit. So this is the first machine that prepares the material for the entire process. Okay. Then we have a second machine that expects the material preparation. So whenever material is being prepared, the second machine, which is the robotic cutting, will be waiting for the materials to be ready. Okay. So if I have any stoppages in the first machine, I also want to stop the second machine as a downstream stoppage, as the previous machine is not operating. I don't want the second one to operate as well. Okay. Then we have the third machine where there's a thermal hydraulic molding press, and basically we're preparing the product, the final product, and making it ready for selling. And then we have the packaging station, which is the last station. Okay, so these are the 4 machines that I'll be monitoring this application. As you also can see in this first screen, we have the global OEE for the entire factory. So you can check the quality, the availability, and the performance of the entire plant. And we can also check each OEE and each indicators for each machine, as you can see in the boxes here. Okay. All the 4 machines are running. You can see by the status green. And let's go to the second one. This is the second screen that I prepared. And here we have more information, such as number of units produced versus the total shift that I'm expecting. Number of units produced versus the expected number of units by the moment that we're checking here. So this shift started 47 minutes ago. It started 12 p.m. here in Brazil, and it will end 1 hour. So it's a 1 hour shift that I created, and it's producing the first batch number, which is batch number 1. Okay. We can also see other information here, such as how much percentage it requires to finish and achieve the 100% expected production. So right now it's still 30% of the total. And meeting target, we can see that it's close to the expected target. So we produced 112 units, and the expected at this moment would be 114. So you can see that the target is very close to the expected. So we can move to the next one. Now we have the downtimes. In this screen, I can simulate some stoppages. Of course, in a real scenario, we will have sensors to detect some stoppages. Maybe it's going to be manual intervention to stop a machine. But all these status changes from the machines needs to be recorded. It's important to calculate the OE. It's important to understand what type of stoppages are causing most of the downtimes in the factory and most of the losses. So it's very important information that we want to store in the database. Okay, I will just show you one of the stoppages here. I'm going to be stopping the thermal hydraulic press. And I can choose between planned and unplanned stop. I'm gonna just stop for a maintenance. As you can see, the status changed to red. Availability is gonna be start dropping, and you can see the reason for the stoppage is also visible here as a maintenance. Okay. I also have some other information about meters. Energy consumption here. As you can see, the machine is stopped here, and you can see that the meter active power is dropping because it's not consuming that much energy right now. But not very important right now for the presentation. I want to show this screen here, where is the expected rates of production for each of the machines. So here we can basically define what is the expected versus what's happening right now. So if I expect to have a new piece every 10 seconds, for example, I need to configure here. I can also configure the batch number, the shift that we're operating, everything in this configuration screen. Okay. And I can also simulate some wastes during the production. So let's say I'm doing the packaging station, and one of the packages failed the quality test, and it needs to be redone. So I can also register these wastes in this screen here. And this is all going to be used later by Insight View as well. Okay. So here we have the SCADA that, like I mentioned, and I have implemented a few things that are going to be very interesting, such as using the rule base to uh, present some information to the users. For example, let's say I have a stoppage here, and if whenever I have set up and adjustments, I want to call a specific team to handle this stoppage. So they're going to be going to the machine and taking the actions that are required. So depending on the machine and the type of stoppages, we can assign different teams to handle this stoppage. Okay, so instead of programming this as services and scripts and using different logics, I decided to use the rule-based system, which is a very nice tool that we can use to guardrail the everything that's happening in the production. So I don't want to take any wrong actions without actually analyzing what's going on in production and using the rules as this guardrail, so I won't take any wrong decisions. Okay. So in this example here, so let's just go back. I'm gonna add a setup and adjustment stoppage for the packaging. As soon as it stopped, you can see that I just got a new visible tip here that says call support for 1404. So this could be an example. Whenever I have a step setup and adjustments, I want to call this specific team to take a look and reestablish the machine. Okay. I also have some other rules that I created. And first, let me show you the rules, and then we can go back to the application. So basically, I have two rule sets. One is related to OEE monitoring. So quick actions, that's what we just saw. So for example, whenever I have any setup and adjustments stoppage, in this example, I want to call support for 1404. But if I have equipment failure, I want to call the maintenance on another number, which is 1501. Okay. So basically, this flowchart uses the rules to make decisions. So whenever I have a machine stoppage, so this is the first box here, as you can see. If the identifier, meaning the status of the machine, is different than 0, I want to stop the machine and I want to take actions on this stoppage. Okay, so if this is true, I will be evaluating these three boxes now because they are creating the true paths. So all the three boxes or the rules here are going to be evaluated. So first one, I'm going to check if the reason for the stoppage is lack of material. If it is, I also call the support. Or, so I'm connecting both of these boxes here. So any one of these, whenever they met true, I want to call the support. So setup and adjustments, we just saw it. So this was evaluated to true, and then we call the support as an action. And we can have multiple actions here. In this example, I'm just putting a visible information on the screen so users can call the correct team as fast as possible to make the decisions. But I could also be maybe changing a tag and assigning a new value to the POC. I could be sending emails. So I have a lot of options in the actions boxes here. So I can create a very interesting and also complex logics here to handle the execution of this application. Okay. The third one, which is not part of this call support, is the call maintenance. And like I said, we're just checking again the reason against the equipment failure. If none of this is true, meaning that the identifier is equals zero, right? The status of the machine is up and running. We just want to clear any tips or any visible information that we added to the screen. So at this moment, if I restart production, we're going to be removing here due to the rule base or specifically to this box here because it evaluated to false. Okay. So this is one of the rules that was added. I also added some other rules such as detecting low viability, low performance, low quality, and generating some logs here. Okay, so I could also be taking other steps to not only to help the users but also to make changes in the production, maybe to uh, change the current status where availability is less than 70% or performance or quality. Okay. I've also created a second rule-based system rule set here, which is checking for starvation. So as I mentioned in here, whenever I stop the first machine, I also want to stop the second machine because it is directly connected to the first machine. And if the first machine is not producing, I just want to stop and wait for the first machine to start. So if I stop this machine, it doesn't matter what is the motive or the reason of the stoppage. So for example, lack of material, I want to also stop the second one. So that's what you just saw here. So you can see that the second machine stopped automatically. We can also see that it was stopped by starvation because the first machine is not producing anymore. And it shows the reason for the stoppage, which is blocked by downstream equipment. Okay. So this is done only in this small rule here. And that's very interesting because what we can do here, we can check the status of the first machine, which is the identifier. If it's different than zero again, we're going to be basically changing the second machine, which is the second index here. I'm going to be inserting a new event in the database. And this is important because, like I said, all the events that we register in production, whether it's a new item being produced or if it's a downtime, this needs to be informed in the database because later we're going to be also using the Insight View to collect this data and prepare analysis. So here I'm basically stopping production. I'm inserting the event 11, and this event 11 defines the starvation, okay, the downstream equipment block. I'm also setting this information that we want to see in the screen, and that's it. As soon as we reach, as soon as the first one stoppage happens, the second one also stops automatically, and then we also set a starvation flag here because I want to show in the screen some information. So if I open the downtimes in the engineering environment, you can see that this message here is only visible when starvation is happening. Okay, so this is the relationship between both machines created by the rule-based system. So as soon as I start this one, I can also restart the second one, and now both are going to be executing until something happens again. Okay. So all this data is being sent to the database. Basically, we have production happening. So we can see that the numbers of units are still being added to the total. And we can also check, just a second, and I'm going to be opening now Insight View and Knowledge View because I want to be able to see all the data that we've been seeing in the plant floor. And I want to be able to see this also on the cloud, but I want to get more information. I want to be able to see reports. I want to see the 6 big losses. I want to be able to see some charts about what's happening this year, this month exactly. So I want to extract more data, and Insight View provides a lot of tools where you can now analyze better what's happening on production. Okay, we just saw that numbers are dropped here. So we just restarted a new batch and a new shift. So that's why the numbers just restarted as it's 1 o'clock here in Brazil. So in Insight View, we can see the 4 machines here. They are all the 4 are executing right now, as we can see. But we can see in a different range. So basically here I'm seeing the OE in the last hour. I can also change the filter if I want to know what was the OE for the last 24 hours. I can also change the filtering. If I just want to check the OE for, let's say, the last shift or the current shift, I can also use some tools here to check all this data. Okay, so this is the first screen as the dashboard. All the data was already configured to load the database data that we are storing using SmartView. So, like I said, the events are being stored in the database and also the production. So, whenever I have a new unit produced, I need to record it in the database. I want to know what was the timestamp when this unit was produced and so on. Okay, so all this data is already in the database. So, when we move to the Insight view, basically here, I'm going to be able to configure factories. I have options to configure multiple factories if I have multiple machines that I want to monitor, and these machines doesn't belong to the same factory. It's okay. We can also uh, monitor different companies, different areas, different sites. So in this example here, I'm using the FPC factory, and this is the only site that I created. Under this site, I have warehouse area. And under this area, we have all the 4 machines that we're monitoring. Okay, so we have, like I said, material preparation, robotic cutting, thermal, and the packaging station. Okay, so what we see here, not only these 4 machines, but I have also other machines that I have executing under the Insight view. And I want to see now information about, let's say, let's manipulate a little bit here. So let's do the same stoppage that we've done before. I'm gonna stop for quality inspection, the first one. I want the second one to stop as well. And here we're gonna be able to see all that's happening in production. So we just saw that robotic cutting changed, and it got the color red as it's an unplanned stoppage. But we also have the material preparation, the first machine stoppage as a planned stop with quality inspection. Okay. So we can see all this data. If I want to take a look closer to this machine, I can also access the OE overview screen. And this screen, we can change the filter. So if I want to check how was the OE for this machine yesterday at the same time of the day, I'm able to customize the filter range and check what was happening yesterday or the month before. Okay. I will leave it for the last hour as we have 1 hour shifts, and we can see what's happened to this machine. So on the left side here, we have the percentages of running versus the unplanned and planned stoppages. So right now we have 93% of running status. So this is the availability. We also know that the performance is 82% for this machine, and we have the quality 100%. So meaning that the quality of all the units produced are a good production. So I didn't have any waste so far. And performance, we already saw that uh, we are not producing as fast as expected because of some configuration that I've done here in the target. Okay, so all these 3 indicators, they cause that the OE calculation drops a little bit, of course. And as close as we get to the 100%, better to the factory and to the customer. Okay. So moving down, this is the status of what's happening in production right now. So we just got the planned quality inspection. So you can see that the current status is stopped. And as soon as I start both machines here, we're going to be able to see the status also updating in this chart. So just need to wait a few seconds and should be here. So now we can see that the status is up and running again. And We can move down to the KPIs, such as downtime information. We already saw that the last stoppage was quality inspection. We can see that the quality inspection is also visible here, but we can also see the other stoppages that we had. So we had the lack of material here and the lack of material here again. So we have two lack of materials versus one quality inspection. We also have a downtime that's just for the change of the shifts. So it's a very small downtime. You won't see any time registered here. But regarding the other two stoppages, we can also check the duration of each of these stoppages. How much did it represent? So the first one, lack of material, it represented 3 minutes and 4 seconds in the last hour, as we are filtering 1 hour. And the second one, quality inspection, duration was 2 minutes and 12 seconds. Okay. Here we already saw that we also have the information about wastes and good production. And right now we have a quality of 100%. So what other insights we can get from Insight View? We already saw OEE overview, which sums up production in a range filter that we can apply. So if I want to check how was the last month OEE, I can also filter the entire month and check how much of duration of stoppages we had and what was the availability and so on. And if we want to monitor what's happening right now in the current shift or in the current batch, we can also use the second screen here, which is the OE real time. Okay. Like I said, this shift started 1 o'clock and it's 1 hour shift, so it should stop 2 p.m. here. And as you can see here, that run started 12:59:08, and the estimated completion is 2 p.m. Okay, so its actual run is just 7 minutes and 50 seconds. We can also see the availability, performance, and the quality of this current. In case this is the current batch, but I can also change to the current shift. And both are working very close. We can also see that since we have some downtimes here, the actual production is not reaching the ideal production at this moment. But this chart is interesting because you can see how much it requires to reach the expected. And of course, if we didn't have any stoppages, we would be close to the ideal here. And just the performance would drop a little bit because my simulation forces some performance drops. Okay. This second chart here is similar to the one that we just saw, but now specifically for this current shift. So we can see that we started running, then we have 2 minutes of stoppage, and then it's up and running again. We can see the downtimes count and the duration, and we just got the quality inspection so far in this shift. And we can also check the production. So number of units produced here. Okay. If we go to the target, I can force some wastes if I want to see the quality drop a little bit. And probably the next unit here is going to be added as a waste if I change it the correct one. Yeah, I have two wastes here actually. Okay, we just got the first waste and it says fail quality test. So this is the reason that I'm applying when I store this failure in the database. Okay, but I can also give different reasons for the failure, such as I don't know, issues with the piece that was produced, or not only the quality test, but other reasons that I want to record in the database. Okay. So this is the real-time OEE, where we can get information about the shifts and the batches that are being produced right now. We also have the 6 big losses, and this is a very interesting chart because the idea is to, as soon as you take a look at the chart, you know where we're getting most of the losses. So as soon as I put my eyes on this chart, I know that this row here represents most of the losses that we're getting in the last hour. So what is that? This is basically slow cycles. Like I said, I'm simulating some performance losses in this machine. For example, if I'm expecting to produce 5 units in a minute, I'm basically doing 4 pieces of unit in a minute. So we're losing some performance, and we're not producing as expected by the machine. Okay. We also can see in this nice chart that we have some planned stops as well. So we have 2 minutes of stop in this last hour, 3 minutes of unplanned stop as well. Small stops, we didn't lose any seconds because it's just the change of the shifts and the batches. So I'm doing it automatically. Of course, in real life, we may lose some time during the shifts changes, but in my sample here, I'm not spending any time when I'm changing shifts. Okay. We have production rejects as well. So these are all the losses that are very important to be aware. So we have the 6 big losses for each of the indicators that we have. For example, quality, performance, and availability. We're going to have 2 major losses for each of them. Okay. So for the quality, if we're talking about quality, we want to understand what are the rejects, how many rejects we're producing, because at the end of the day, if we're producing too many rejects, it's no good because the OEE will drop, right? We are not producing as much as we expected because these rejects won't be sold. We also have the startup rejects that can be represented. So maybe we're just starting production. The first pieces are going to be rejected because we're just warming up the machine. So is also going to be recorded and represented in this chart here. Second one is performance. As we know, performance indicates if the machine is running or stopped. And we want to know what's the reason for the performance. We want to know if we're producing during the production time. I don't want to consider when the machine is stopped, but when it's producing, if it's producing as much as we expect. So like I said, if we're expecting to produce 10 units in a minute and I'm producing less than this, I won't get the 100% of the performance. So in this case, I'm forcing some slow cycles. So in my sample application, we're not producing exactly as fast as the expectation. So that's why we see some slow cycles here for the performance. Small stops, I didn't represent any here. Okay. And then we go to availability. Availability, we have also the percentages of unplanned and planned. These are the most important losses of availability. And we need to be aware because if we're getting too many unplanned stops in production, this is something that we need to evaluate. Why the machine is stopping, let's say, every week and it stops for 1, 2 hours uh, without any maintenance being done before, because maybe if the machine is stopping too much, we need to assign maintenance, we need to take care of this machine. So that's why these 6 big losses are very important, because the customer, the user, can also extract information to try to avoid these numbers in the future. Okay. Moving forward, we also have the reports. Okay. I have some gaps in my reports because I've been testing. This is just a sample application, but I can show you, for example, shift 13, which is the one that we just finished. And as soon as we finish a shift or we finish a batch, I'm going to be recording historical information of what happening during this shift or during this batch. Okay, so if I change to batch, I'm going to be seeing the batches. And if I change to shift, I can see the entire shift. Okay, so this is 1 hour shift. If we click details here, we can check the availability that was calculated during the shift 13. When it started at 12:30 in Brazil time, and it ended 30 minutes later. So this wasn't a complete 1 hour shift. We can also check the product name, product type, the ideal rate for this machine, what's the name of the machine that I'm checking, what's the area, site, and company. We can download this as a PDF and send to the important responsible people in this. So basically, we can also check all this data as a PDF, and we basically can see what happened in each of the indicators. So if the availability we're expecting to produce in 31 minutes, but in fact I produced only 28 minutes, we got some losses here. And we can see the losses like a lack of material. For example, we can check the performance. So expected quantity would be 172, and we basically reached the entire performance. And the quality, we didn't have any losses, so also 100%. This screen also provides access to administrators to make some changes. So let's say we did have some wastes in this production, in this shift, but we weren't able to record the wastes during the shift production. So after the shift ended, I'm able to change as well the number of waste units. Okay, so this is done only by the administrator. Since we have all this data here already, we can search for shifts. For example, if I want to compare shift 13 in other days, I can also filter by them and compare what's going on. But I can use the charts. So we have two options of charts that will get the historical data for the shifts and the batches. Oops. Let me just reconnect. So let's go to the material preparation. So I want to see the downtimes. So let's see for the entire year of 2025. This is a very new machine that I implemented, so we won't have too much data to see. But basically here, I can see for the entire year of 2025 what downtimes that represented most of the stoppages in production. So a very important insight because we can take actions over it. So if we're getting so many lack of material, that in this case represented 87% of the total stoppages that we had. This is something easy to fix. We just need to make sure that we don't have lack of material and we're able to order in advance whatever is going to be needed to the production. Okay, so we won't have lack of material and we won't have to stop the machine. So this is something that, like I said, it's an insight that we provide to the users, and they can take actions, the correct actions to improve the OEE. We also have some lack of operator and downtimes registered here, but this is the information for 2025. I can also evaluate by month. In this case, I only executed this month, so I won't have too much information to see. Let me change to the second chart now. So we've seen the downtime charts. We can also export as PDF and send to other users. And we have the OE charts. So for the OE, I basically can see month by month the OE. In this case, like I said, this is a new sample, so I only have for December. But I can also check daily. So if I want to check in December and check the OE, you can see that I executed on the 5th, yesterday and today. So we have just three history data for December, but very interesting information because I am going to be able to compare what's happening the entire year, compare results, and also check by shift and by date, so I can extract more information about it. So now I'm just checking the shift, as you can see here. On the 5th, we had these shifts production, and I can also check the OE for each of the shifts. So everything can be downloaded as a PDF and sent. Okay. Okay, apart from the OE, we have some other tools that are interesting, such as the dashboards, alarms. I will talk a little bit about the alarms first. In the alarm management screen, we can also send emails, for example, whenever the OE is below 80%, or maybe let me just create a new alarm here. But let's say I'm going to be selecting the factory and the site and the warehouse, And then I can assign a alarm for one of the assets here, for example, robotic cutting. So it's going to be an insight view evaluation. I want to be able to check, for example, I have access to verify each of these information, such as if the ideal rate is below 10 units per minute, I can also generate an alarm. If the shift changed, I can generate an alarm. This is interesting because I can also receive by email whenever a new shift started. In this case, I wouldn't be putting critical, I could be putting as just a warning. And I'm going to be using the rule for the shift on change. So whenever the shift 13, for example, as you can see here, change it to shift 14, I would be generating a new alarm there. Okay. And basically that's it. So I can create multiple alarms to the insight view and knowledge view for the screens. And then in the action, in the alerts, I can also assign an email to receive what's happening in production, basically. Okay. So all these alarms can be sent by email, but not only by email, we can also see visually here as we have alarm visualization screen. We have notifications for the alarms as well. So whenever a new alarm happens, I can click here and acknowledge this alarm. Okay. And we have another visual as a timeline. So here I can also filter by machines and filter specifically by types of alarm, if it was already acknowledged, if it's pending, if it's required or not. And I can also filter by time range. Okay. So it's also a nice thing tool here to analyze what's happening in production. Moving forward, we have the dashboards. And dashboards now can be used to multiple purposes. So since we have this specific machine, four machines executing in the warehouse, in the asset that in the area that I mentioned, in the site and in this company, maybe I want to in the future be able to compare this installation against a second installation very similar in a different location. Okay, so let's say we're doing the same production. We also have the packaging, the robotic cutting, the thermal press, and the material preparation machines, but in a different site. So I want to be able to compare. I want to see if the OE in the other site is above or below our OE in our local site. I want to learn from them. So if we're using the same machines, but my machine is doing multiple stoppages, unplanned stoppages, and the machine that is executing there doesn't have any, maybe it's important to understand why not. Maybe it's the operation, the way the shift and the operators are working. So maybe the stoppages are happening mostly in the morning, not in the night. So all this data is important. And the dashboards are an important piece because we can compare results between different factories. So first one is just, oops, that's just a breakpoint. Let me go back. Okay, so here I can see the OE for the four machines. But if I have multiple factories with multiple machines as well, I could be putting side by side, for example, I could be putting side by side, for example, the material preparation in factory one versus the material preparation in factory two, and so on. So it's a nice tool to be able to add dashboards, and you can add as many as you want. So if I just click here and I want to add more information now, not about the material preparation, but I want to check the hydraulic system, for example. So I can also add this and check the OE for this specific machine and add it below to the dashboard that we just saw. Okay, so now I have a fifth information. This is not executing right now. That's why it's 0%. Okay. I've created some other dashboards here as well, such as production. So what's happening right now with the units we are producing in each of the machines. So we have a number of units produced in all the four machines that we have. I have also created a third one, which is just status. So we can also see side by side what's the status of the machines right now. Okay, so you can see that the material preparation and the robotic cutting have all the same stoppages, because whenever the first one stops, I created the rule that stops the second machine. Okay. Do you have any questions? I'm close to finish this presentation.
Yeah, so are there any questions that we might have? Any questions? Hold on one moment. I think I see some coming in. Hold on. So one of the question is more on, I think this is the whole benefit of being on premise, but I'll say it the two different ways it was asked. Does SmartView support operator input from downtime reasons? And the other one is, can a Deershire SmartView run the OEE calculations even when the network is down?
Mhm. Yeah, the Smart View is executing locally here, so it's going to be storing in a local database, or at least in the network factory database. So it doesn't require internet access. But for Insight View and Knowledge View, as they're running on the cloud, they require a connection. So could be maybe the database is also on the cloud, so it's going to be easier. And then in this case, SmartView won't be able to store it. But here is where you can configure the database for Insight View. In this case, I'm using a local Postgres in my machine, and you can create the connection here. But if it was on the cloud as well, you could have a second or third database here and use all of them. So that's how we actually relate data between both systems. Not sure if I answered the first one, Marcia. What was the first one? Hello?
Oh, I'm
Okay,
sorry.
do we
Am
have
I
more
on mute?
questions?
Yeah, I'm sorry.
Yeah.
I was on mute. I'm sorry. I didn't even realize that. Um, how you link into info from a Deershire Smart View to a Deershire Insight View dashboard? Is it via web pages created inside of Deershire? That's one of the questions.
Yeah, the dashboards are, let me show you better here. So the dashboards, whenever I create a new dashboard, let's do it. I'm going to be defining basically what I want to see on it. It's the name of the dashboard, so I'm going to be just creating as a general. And I can also specify the visibility of the dashboard. So it's if it's public, whenever I have other coworkers that want to see this dashboard, they're going to be able to see as soon as I change it to visible, public visibility. If it's private, it's only my access. So if I create a new dashboard here as a general, I can now edit it. I can, let's go back and open the dashboard that I created for general. And this is the initial dashboard. So I can add as many items as I want. I can drag and drop items here. So it's basically a page that receives different types of items that are important for production. In our example, I just showed you some Insight view. So if I select for thermal molding, for example, I have 7 options or more for Insight view. I have knowledge view data as well, some energy management that we're adding to the product. So for example, OEE that we just saw, we have the stoppages, we have the time summary, we have also the stoppages in minutes and in counts that we saw in the other screens. We have information about monitoring tags. So I'm also able to select some tags that I'm controlling in the SmartView in the SCADA. And as soon as I save this tag to the database, I can also be able to plot that data in here. So it's also interesting because maybe we just want to check what was the temperature of the thermal hydraulic molding press. It's not part of the calculation for the insight view or knowledge view, but it's still an important process variable. And I want to be able to see in insight view. So I can also store this in the database, and then I can come here and select the tag to be also added to the dashboard. Okay. We have some real-time other options of like these gauges here. So I can also plot the information. I have a cylinder. I have booleans, for example, on or off, if I want to add a switch or a button, checkboxes. So there are different options of visualization as well for this. But basically, it's a empty screen where you can add multiple items and just reorder them, reorganize them to be able to compare different assets.
Since I want to respect people's hour, the 1 hour mark, and it is 10:30, I will send you the three questions that we didn't answer, Fabio, and we can answer it offline and send it to everybody. Does that work?
Mhm. Yeah,
I think, and so I do appreciate everyone logging in, unless there's a compelling question. If you have questions that we did not answer or we didn't get to, can you please, send it to info@adeersford.com and we'll make sure to get them answered as well. But the three that we did receive, we will answer them offline and send them to you. We appreciate your time. This recording will be available, and we do hope that you also answer our survey so we can continue to improve these webinars as we enter 2026. Thank you so much, and we appreciate your time today. Have a wonderful day.
thank you.